When we write applications that are of a larger size, like a line of business application or enterprise level applications, a lot of times we have to deal with a lot of classes that have a lot of dependencies. Services need data access. Controllers need services. They need other classes to get their job done. And so when we're putting together an application like this, it's important to talk about a strategy that's very common when we're dealing with applications of these sizes, and that's dependency injection. Dependency injection is one way we follow a pattern called inversion of control. Inversion of control is the concept of allowing something outside of a system to control it. A lot of times when we think about some entity, especially in programming, we're tempted to put everything that controls that entity into the entity itself, everything it's responsible for. And inversion of control is a principle that says, let's see if we can remove some of that responsibility from the entity. So in a large sense, having, for instance, a web front end to a database is an example of inversion of control. You don't log into a database and make the changes there directly. The control of data entry has been handed over to some other system. And so that's one example of how we might work out the inversion of control principle. It's a way of taking unnecessary responsibilities out of systems and delegating them to systems that are better equipped to handle it. Dependency injection is one of the ways that we do this in applications, and we're trying to answer certain issues. It's mainly the issue that methods need objects to do their jobs. We very rarely can get away with writing classes that don't need any other classes. In fact, if you've written a large application in that way, probably it's not the best written application there is, because you have classes with tons of responsibilities, your code is very tightly coupled to the things that it manages, and it's just going to be very difficult to test, and it's going to be very difficult to change. So, for instance, if you've got a book class, and not only does that define what a book is, but it also defines how the database is going to store that book, and it can execute that database storage, and you've got query methods in there to query for different kinds of books. Well, that book class is just doing a whole lot, and that's really hard to test that class, and it's really hard to make changes that aren't going to break everything. What if you change databases? What if your ORM changes or your database structure changes? You're going to be changing that class a lot. So what we want to do is we want to take those dependencies like data access, business logic, that's service-oriented, and we want to move those out to other objects so that they can come in from the outside. If you walk into a pizza place and you order a pizza, you'll see them probably putting the pizza together there, but what they aren't doing is processing cardboard to make boxes out of. They're not growing tomatoes out in their backyard to harvest, and they're not slaughtering cows for the hamburger pizzas. They're not doing all that stuff. All those dependencies that a pizza store has comes in from the outside. Because if that pizza store were responsible for all of those things, then it would take forever to make a pizza. And probably it would end up doing a lot of things not very well, as opposed to just focusing on the responsibility of assembling these components and giving them to you to eat. And code is not entirely different from that. If you have a piece of code that's doing 80 different things to get the job done, it's probably not doing any of them well, and that process is really fragile and bloated and long. And so dependency injection is writing our code in a way that these dependencies can be brought in from the outside. Just like a pizza place, it orders its boxes from somewhere and it orders its ingredients from somewhere. It doesn't produce those themselves. Well, this in and of itself can be kind of a code-heavy process, because if you think about it, pretty much all your code at all your layers would have dependencies if you really broke them up into discrete units of functionality. And so who wants to go through all their code and fire up all those dependencies in every class? It's time-consuming. But not only is it time-consuming, if you were to do that, go to every class and say, in the constructor, instantiate all the objects that class needed, well, you're tightly coupling that class to those particular implementations. So you can't test that class because it's using real implementations. You can't just send in fake ones. And if you make changes to any of those implementations, you've probably affected your class in an adverse way. So the whole idea of dependency injection is your classes don't even instantiate these things. It just depends on interfaces, and you have something to inject them from the outside, hence the witty name. This is often accomplished with the use of dependency injection frameworks. People have written frameworks specifically to deal with this issue. You can do this yourself, and in fact, the Web API offers several ways to do this yourself. And if your project is relatively small and lightweight and you don't need a full-blown system to do dependency injection in lots and lots of classes, using one of the built-in Web API ways to do this may be the way that you choose to go. However, most applications of size accomplish this with the use of dependency injection frameworks. They don't rewrite all of that themselves. And you've probably heard of some of these. Here's just a basic list of some of them. It isn't exhaustive, but Castle Windsor, for example, is a very popular dependency injection framework. It has a lot of other features attached to it as well. Structure Map, Ninject, Unity. This is the one that comes with Microsoft's application blocks. Spring.net. This is a .NET port of the Spring framework for Java. And all of these frameworks differ somewhat in syntax, and they differ somewhat in what features they offer. Some of them are huge collections of features. Some of them are extremely lightweight, and there's even others I didn't put on this list, like AutoFac and other DI frameworks you may have heard of. But they all basically are trying to accomplish the same thing. They are all an automated way to tell your classes, hey, if you need data access, I'm going to fire up a data access object and give it to you. Hey, if you need a service, I'm going to fire it up and give it to you automatically. And that way classes don't have to manage their own dependencies. So how is this applying directly to the Web API framework? Well, it applies to the Web API framework because since the Web API recognizes that this is an extremely common way to deal with these large-based applications, it's put in hooks for us to allow us to wire up how we want to do our dependency resolution. If a class has dependencies, how do we want to take care of that? And some of these ways are ways that we can code ourselves, once again, suitable for smaller projects perhaps. But they also recognize that dependency injection frameworks are a very common way to take care of this issue. And so what is provided us is a way of working with dependency injection frameworks that are very similar to the other resolution methods that are built in. But instead of wiring up those built-in things to code that we write ourselves, we're going to wire up those built-in methods to a dependency injection framework for it to execute. So we're kind of delegating things that we might write ourselves to this framework. It's important to note that most line of business apps will benefit from this, and anything that's above this in size. If you've never used dependency injection before and you're working on applications that are of this level of size and complexity, you're probably running into issues where you are more tightly coupled than you want to be, and you are writing code that can be very difficult to test without actually running through the entire system. How do you get data into a service class? Well, if you're using dependency injection, you can just make a fake data access object and have it return fake data. If you're not using dependency injection, then you're pretty much going to have to hit your database, which may be okay, but when you start testing your inserts and updates and deletes, you're going to end up with a lot of weird data in that database, which once again may be all right, but it's not ideal for testing. Now you're testing a whole integration of a system instead of a specific piece or a specific responsibility. So if you are developing line of business apps or enterprise level apps, or even apps for yourself that are just big, really think about how the Web API can offer you an easy gateway into dependency injection, because I think you will find that you will be writing much more stable applications and much better code overall. So if we want to use a dependency injection container, the Web API provides a way to wire this up relatively quickly. But it is a little bit different than if you've tried to wire up dependency injection containers to some of the other frameworks that might be out there. Like even the MVC framework wires up its dependency injection a little bit differently. So let's walk through how to wire up a dependency injection container to the web API and then show us what that can buy us in our code. I'm actually going to start here in the global.asax because I want to start where we are actually going to connect our resolver. And the reason that I want to do this is because there are several different ways that we could use the global.asax to wire this up. I'm going to show you one way. It's the way I think works best, but I also want to point out a few different side roads you could go down if you would rather do it that way. So the first thing that I want to do is start here in Application Start, where we do all our configuration for the Web API. And what I want to do is I want to tell the Web API framework that whenever you see a dependency that needs to be resolved, use this resolver to do it. And so I happen to be using structure map as the dependency injection container here. This would be a very similar pattern for any DI container you decided to use. There's nothing particular about structure map that makes it better in this case than any others, so feel free to use the one that you like the best. But in this case, I'm going to create a variable to hold the container, the structure map container. And what a container is in structure map, it's also called a container, I believe, in Unity. It's basically keeping track of all the dependencies that you have in your code and all the objects that those dependencies are going to need to do the jobs that those dependencies are going to do. So you might think about structure map or any DI container as a collection of objects waiting to be plugged in where those dependencies are needed. So that's why it's called a container, because it holds the mappings for these instances. So in structure map, we refer to the object factories container. Okay. Now here's where we start to see this wire up specifically to the API. So I'm going to come down here with global configuration. This is how you configure a lot of things in the web API. This is how we plug in lots of code, filters, message handlers, all that good stuff. And notice one of the things we can plug in is a service resolver. And what we want to do is we want to set this resolver to a particular thing. Now, this is going to be the exact same thing you do no matter what you use to resolve your dependencies. Whatever you use to resolve your dependencies is going to go here, even if it's something you write yourself or something more lightweight. The only thing that's going to change is what goes in these parentheses. So even as you look at other methods of doing dependency injection or resolving dependencies, you're still going to be using this code. The only thing is, in this particular line of code, I'm actually going to wire this up to the structure map container. Now, this looks okay, but the issue is I haven't really told it what to do with this container. So I've said I want to use the structure map container to resolve my dependencies, but I haven't told it exactly how this is going to happen. I mean, structure map has its own methods that it uses with the container to resolve dependencies. The web API does not have code for every single dependency injection that might be out there. And so what we want to do is actually wrap this in a class where we can expose some of these methods that the web API does recognize and just implement those methods with structure map. So instead of just setting a resolver to the structure map container, I'm going to do this. Now I have not written this class yet, okay, as you can see, but I will so you can see how this works. What's going to happen is when I set the resolver equal to this class that I'm writing up, this class is going to be a wrapper for the structure map container. So I'm going to implement an interface that this method understands. This method understands a particular interface. I'm going to implement it with this class and just tie all the methods to structure map methods, and then I'm done. So let's go ahead and write this, and I'm just going to add this to the root here. I'm going to create a class called structure map resolver. And the key thing that this class needs to do is it needs to implement dependency resolver. This is an interface that your global.asax will recognize, and it knows how to call these methods. So we're going to pull this out of the right namespace here, HTTP services. It recognizes this interface, so whatever code we write that implements these interface methods, global.asax will already know how to process it. So I'm going to say to implement this interface, and it gives me two methods here. So basically what I have to do is I have to tell the web API what to do when it has to get a service, and it's a single one, or what to do when it has to get a collection. So it's going to have a type. This is probably going to be an interface, and somewhere in here I need to tell it to get the concrete implementation of that interface. When we go to look at code that uses this, I think you'll see this a lot more clearly than perhaps you might right at this second. But first, I'm going to go ahead and make a constructor here. And it's going to take a structure map container. Here's the thing. You can't write an application that has no coupling. At some point, you are going to need to tell your application, I actually need a concrete implementation. One of the things that dependency injection buys you is I can do it here. I just bind it to concrete types in my structure map, and then the rest of my code doesn't need to be tied to any. You can't totally eliminate coupling from your code, but what we are doing is minimizing it and localizing it to one particular known location. And when it gets passed in the container, what I'm going to do here is hold this in a private variable. Like that. And it'll just hold whatever we pass in, which is the object factory's container. The reason why I like to pass this in as opposed to just referencing the object factory here is now I don't technically have a hard dependency on structure map. If I want to actually use some different kind of container, I'm free to do that, and I can just wire it up to whatever dependency injection framework I want to use. In this case, I happen to be using structure map, but this is flexible enough that I could rewrite it if I wanted to without changing any of my other code. When it has a dependency, a service type, an interface, and it needs to find the concrete implementation, how's it going to do that? So what I'm going to do is, first of all, I'm going to say if this is abstract, or if this thing that it needs is an interface, then I'm going to tell structure map to try and get the instance of whatever the service type is. It's got all the mappings. This try get instance, this is just a method that comes packaged with structure map. This is just how it, well, tries to get instances. So I just said, so structure map, try to get an instance of this type. Otherwise, then I can just return a concrete implementation. Okay. All I'm doing is delegating to structure map methods here. I'm just making a wrapper that the web API understands. It knows to call this method, and all I'm doing is using those methods to wrap structure map stuff. And if I wanted to use a different DI container, then I would have Unity stuff in here, or however I wanted to implement that method. Okay, so now what happens if I need to get a collection? So all I do, once again, is just delegate this to structure map stuff. And I'm just going to ask it to get all instances where the type is the same as the type that was passed in. So the reason you have to do this is because sometimes you might have an interface that could be implemented by more than one object. In fact, that's not terribly uncommon with some interfaces. And so you got to have this method. So if you've got an interface that's implemented by 2, 3, or 4 different classes, this can go ahead and get all of them. And then once you have all of them available, you can choose which one you want to use. So that's really all it is. I'm using the get service method and telling it what to do, and I'm just using structure map to do it, or getting a collection of services telling it what to do, and I've already wired it up here, so I'm good to go. And that's really it in terms of configuring the web API to use a dependency injection container. So the question is, now that I've done that, why do I care? Why would I ever want to do something like this? Well, if I go back to my controller code for books, you see what I've got here. I need a repository. I need data access. And what I've done is I've actually made a concrete implementation of the book repository. And that works fine, but here's the problem. How could I test this without an actual database? Well, I couldn't, because this book repository is a concrete implementation that accesses a real database. I couldn't just put in fake data or whatever I wanted here, and I sure couldn't use a different repository here to get books out of. Maybe I've got book data in another database, so I have another class that deals with that. I can't use that here. I'm tied to this concrete implementation. So what structure map allows me to do is this. Instead of newing it up here, what I can do is take it from the outside. This is inversion of control. So I set it up in the constructor, my iBook repository, just to make it clearer. I'll just call the variable book repository. And now I just set this equal to whatever gets passed in. That's it. That's the only change that needs to happen. But look what happens now. This class does not create its own repository. It will just use whatever it gets. So we just wired up structure map to go ahead and find the book repository that implements this interface, create one, and pass it here. If we want to test this class, then in our test, instead of pulling this out of structure map, I'll just make a fake book repository that implements the exact same interface and pass it in, and now this test is completely testable however we want. Or let's say we have book repositories that go to different databases. So I could have a book SQL Server repository and a book Oracle repository, and they could all implement the same interface, and I could pass in whichever one I need, and I don't have to change a bit of this code. And that's what a DI framework buys us, and that's all you have to do to wire it up.